This is a video lesson on the sine law and something called the ambiguous case. And that is a case where you are solving for a missing angle, but there's more than one possible answer. So first up, an analogy. So moving forwards, 5 squared is 25. And moving forwards, negative 5 squared is also 25. And that means that working backwards, if I took the square root of 25, there would be two answers. There's negative 5 and there's positive 5. Why is that? Well, it's because both of these numbers, when you square them, are equal to 25. So if there are two different values that produce the same result, it means that the inverse of that operation produces two different answers. The thing is that your calculator will only tell you one of those answers. Your calculator will only tell you, if you plug in square root of 25, that the answer is 5. We know that there's also a minus 5. We have to input that ourselves. And based on the context, or let's say in a quadratic equation or quadratic function problem, we would have to know that that's a possible answer. Okay, so we'll keep that in mind. When I show you that moving forwards, again, when I tried two different answers, they had two different numbers, they had the same square. If I tried to take sine of 30 and sine of 150, those are both equal to 0.5. So this is the same idea that two different values, when I take the sine, are equal. And that means that moving backwards, when I take the sine negative 1 of 0.5, there should be two answers. And in fact, there are. But just like the square root, your calculator will only tell you this one. So you have to know that there's another one, and you have to know how to write it out. So what's the connection? Well, here, the answers were both 5. One was positive and one was negative. Here, the answers will both be 8, one positive, one negative. When you take the square root, the connection is that it's the positive and negative of the two different values. So another way of saying that is that we do one answer, the one that the calculator gives, times negative 1, and that's the other one, or that you add a minus sign. In this case, dealing with sine, here are two angles that have the same sign. 80 and 100 have exactly the same sign. In fact, that should be a dot, 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 because it's an irrational number and it keeps going. So if at any point you want to pause and think about what is the connection, if my calculator told me 80, how would I figure out that the other answer was 100? So two other numbers that would have the same, 65 and 115. Those two angles have the same sign. So if I said sine negative 1 of whatever that number was, it would be 65 or 115. 50 and 130 have the same sign. And also 42 and 138 have the same sign. So if you want to pause now and try to think through what is the connection. Like if I did a sine negative 1 and this was the answer, how would I know that 100 is the other one? If I got 65, how would I know that it's 150? So if you want to pause and think about that, now is a good time to do that, because in a second I'll tell you what the answer is. The connection is that if I had one answer, the way to find the other one is that I know the two numbers add up to 180. If I found 80, I would do 180 minus 80 and get 100. I would do 180 minus 65 to get the other. 180 minus 50, 180 minus 42. So how does this come up? Well, in a question like this, if I was using the sine law, this is only applicable in sine law, and it's only applicable if I'm looking for a missing angle. I would set up my ratio. I'd say 16.78 over sine 40 is equal to 20 over sine theta. This, by the way, is the same as if you flipped it. Oftentimes we will write sine 40 over 16.78 and sine theta over 20. And as long as you're consistent, as long as I have the sides, both of them on top and both sine angles on the bottom, or both sine angles on top and both sides on the bottom, that's still going to work. And I would cross multiply, and I get down to a point where I have to take the sine negative 1. Now, as soon as I do that, when I do the sine negative 1, that's the inverse. That's the one that's going to have two different answers. So when I do this, my calculator tells me that the answer is 50, but I know that there could also be 130. So there are two possible ways that this could come up. One is that I can look at the diagram, and I can see that in this case, this angle is acute. It's less than 90. So in this case, I would know visually that the answer is 50. That's one possibility. And the flip side is that I could have a similar diagram. So remember, the numbers here, I had 20 opposite theta and 16.78 opposite 40. If you look at this other example, I've drawn a completely different triangle, but I have a 40 opposite a 16.78 and a 20 centimeters opposite of theta. It's exactly the same setup. And that means that mathematically it will be the same ratio. When I cross multiply, I'll get the same. And when I take the sine negative 1, I'll get the same. But again, there are two possible answers. And in this case, visually in the diagram, I can tell that this angle is obtuse. It's bigger than 90. I can tell that. So that's one way, is that I can tell by looking at the diagram. But number two, the other way that this could come up is if this was written out in words. If I said angle A is 40, side A is 16.78, side B is 20, find angle B. If it just wrote it out in words, I would not know which angle is correct. I wouldn't know if it's obtuse or acute. And in that case, you have to show both. And you have to say there are two possible angles. Angle B could be 50 or angle B could be 130. And that's the idea behind the ambiguous case of the sine law.